Assalamualaikum warahmatullahi wabarakatuh and good morning. I'm Muhammad Omar Abdul Manan, AA 12126. Okay, I'm from section 4, reinforcement concrete 2. My part is to briefing about the specification or the design brief of my project, which is 4-story school hostel. Okay. Firstly, I want to discuss about what the spec we use in our project. Firstly is the FCK, which is we use is 25 or 30 kilonewton per meter square, and the next one is FYK, is 500 kilonewton, and the fire resistant is we use R60. Next one is design life for this building, 4-story school hostel, is 50 years. And the next one is, this is depend on the analysis we use. Slab we use the different, and the foundation we use a different type diameter bar and the thickness. Okay, this is just the overall for the building. And the class we use is XC1 and XC3. The GK and the QK we use 1.5 kilonewton and 3 kilonewton per meter squared for the overall building. Okay. Next, I want to show you the design plan we have here, which is like this. Okay. Okay, I can simplify the plan building, which is we can okay. The plan view of the building is like this, and we are going to analysis many type of analysis, which is slab, foundation, column, stair, beam. Okay. Okay, I think that's all for design brief. So I would like to pass to my partner. Her name is Mali. Okay, thank you.
Okay, my name is Malini Zinanajek, AA12162. Would like to proceed with our frame analysis. For our frame analysis, for in our project, we carry out the frame analysis by considering our building is unbraced structure, because there is no shear wall or lift core that we can do braced structure. But since we don't have that, so we do our unbraced structure. First we do the horizontal and followed by the vertical analysis. Then we combine the both vertical and horizontal to do the shear force and bending moment diagram. So for our frame analysis of the unbraced structure, we are able to draw out the drawing, and we able to determine the shear moment and axial load. For our frame, first we need to find the action on the slab and the beam itself. Next we have to find the stiffness, followed by distribution factor, and then fixed end moment. Then we need to find moment by using moment distribution method, shear force diagram. Then we find shear force and bending moment diagram. So after we did all that, we have obtained certain value that we had mentioned in our report. Okay, so after that, we had choose the frame with the longest, that which we consider it will bear the critical load in our structure. Now we like to proceed with our slab design. For our slab design, we have two type of slab, which is continuous and simply supported slab. For the continuous slab, we had choose the slab that we have sand span, which is 5.4 meter, and it is a two-way slabs. Then to do the analysis of slab, we need to find the slab thickness, which is for hash the LX is over with the range from 20 to 30. So we had decided to use the maximum is 30. Then we need to find the durability, fire and void requirement to find the C nominal that we use for our analysis. Then we need to find action for our slab by using QK, GK, and 1.3 GK and 1.5 QK. To do the analysis, we need to consider the shear force and bending moment itself. Then we can find the maximum shear. Then we can check the deflection and cracking, whether it is pass or fail. And last but not least, we produce the bending moment diagram to find the drawing. So now I would like to pass to my team member to proceed with the next design. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Asmawi bin Madesa, AA122 and 53. So today I would like to present our design for beam. So in our project we have two types of beam. The first one is simply supported beam, and the second one is continuous beam. Okay. Today I would like to show you all add beam D2, 3. So this is the beam which have the biggest load, because at this beam is located at the M&E room. So the at M&E room we have permanent action GK is equal to 6.15 kN per meter square, and for the variable action is QK equal to 7.5 kN per meter square. Okay, and the others characteristic for the materials, for concrete, FCK equal to 25 or 30 Newton per meter square, and for the steel is 500 Newton per meter square. Okay, before we start our beam design, we need to decide for the beam size. So basically we use H equal to L over 13, and for B is 0.4 times H. And for the beam that we have choose to show today, H we have is 500 mm, and for the B is 200 mm. Okay, so after we decide the beam size, we need to proceed to the other step, which is we need to calculate the design action. So for the design action we use is design action we use 1.35 GK plus with 1.5 QK. Okay, for the QK we need to add with the load from the slab. Okay, after that, after finish with the design action, we need to start calculate for our reinforcement. Okay, for the next step is the reinforcement design. So for the moment here, we need to take from the frame analysis, which is the moment must be plus by vertical and horizontal. So after that, after we have the moment from the frame analysis, so we proceed to calculate for the K. and for K is we must less than 0.17, and then for the Z is we must less than 0.95 D. After we have the Z value is less than 0.9 D, so we proceed to decide the area for the reinforcement we use is moment divided by 0.87 times with characteristic for steel and times with the Z. Z is 0. We get, if we get bigger than 0.95 D, so we use 0.95 D. After we get the area for the reinforcement required, so we provide the area reinforcement must bigger than AS value required. So after we finish with the reinforcement design, so we need to calculate for the shear. So for the shear we need to calculate the VRDC, because we need to compare with the VED from the frame analysis. So if we need to calculate and decide of VRDC must bigger than VED. If VRDC is less than VED, the beam is fail. So we need to propose new beam size, or we need to increase the size of reinforcement. Okay, after we finish the shear stage, we need to proceed to the deflection step. So the deflection step, we need to calculate L over D allowable is bigger than L over D actual. So thank you.
Good day. My name is Melissa Goretti Michael, AA12152. So I will proceed with column design for our project. Column is designed according to the load that stretches from the frame to the column. There are two types of column, which are slender column and non-slender column or short column. In our project, we use both types of column, and both columns are bent about both axes, which are XX direction and YY direction. The maximum ultimate load that NED that we use in our project is approximately 1000 kilonewton, and the column size we use in our project is 450 millimeter times 450 millimeters. Firstly, we calculate M over H to compare which equation that we need to use. The moment that we can use is from the frame analysis. So after we calculate for M over H for Z-axis and M over H for Y-axis, and then we compare which one is the greater, and then we use equation that according to the equation. Next, we will calculate for NED over BH FCK and MED over BH square FCK. As we know, NED is taken from the ultimate load and the moment is taken from the frame analysis. After we got the value for N over BH FCK and M over BH square FCK, we find the AS FYK over BH FCK from the table. After we got the value AS FYK over BH FCK from the table, then we can know what is our AS required, and then we provide the AS provided that more higher than the AS required. After we got the AS required and provided, then we can check for the shear and check for the biaxial bending check. For the biaxial bending check, we use equation MED over Z over MRD over Z to the power of A plus MED Y over MED Z to the power of A. And then if the calculation of the biaxial bending is failed, then we need to further check for both axes to satisfy this equation. That's all from me for the column design.
A very good day. My name is Cecilia Analinggang, AA12149. For my part, I'm going to present about foundation. Okay, there are so many types of foundation. Based on our project, we choose a pile cap because from our location, which is at Kuantan, we found out that the strength of the soil is not sufficient enough to sustain the load of the building. Hence, we came out with the pile cap foundation. And for the pile cap foundation design, the first thing that we have to do is to determine the size of the pile cap. Okay, for the number of pile required, we need the service load, we need to divide by the pile capacity. For the pile capacity, we have 600 kilonewton and the service load is 1,400 kilonewton. And after we divided it, we managed to get 2.3, approximately 3 pile cap. That's why we came out with 3 pile cap. And so after we found the size of the pile cap, we may proceed with the main reinforcement and the shear. And for the shear, after the calculation and the analysis, we found out that the number of pile spacing is less than the 3 free pile. Hence, there is no punching shear check required. After the shear, we may proceed to check the cracking, and successfully the cracking is in a good is no cracking found because of the design is sufficient. And then the reason why we choose pile cap, even though we know that piling required expensive than the footing. Why? Because as an engineer, we should provide, we should construct a structure, a building that is safe for the people to stay. So by using the pile cap, we have the responsibility to make sure the building is in a good condition and will not collapse. That's all for my part. Thank you.